guys, today we're going to learn how to use the second derivative test. So before we do that, we need to talk about the first derivative test. Remember, the first derivative test we use to find relative extrema, right? So to find relative extrema, we found our critical points. So step 1, take the derivative. Step 2, set it equal to 0 and solve. And then 3, that's when we set up our sign chart. And we had to know that if it went from increasing to decreasing, it was a max, and decreasing to increasing, it was a min. Okay, that's your main way of finding extrema right now. The second derivative test is going to give us those same things. It's going to tell us our relative max and mins, but it's going to be a faster way sometimes. Okay, so we know that the second derivative, okay, so f double prime of x tells us about concavity. If it's greater than 0, okay, it's concave up. If the second derivative is negative, it's concave down. Okay, so we can plug in a point and see where it's concave up and concave down. If it's concave up, it looks like this. If it's concave down, it looks like that. So what we can do is actually take our critical points and we can plug them in here and here. Okay. If we plug into the second derivative and our critical point is positive, that makes it a minimum. And if we plug it into the second derivative and it's negative, it makes it a max because it's concave down. So basically what we do is, if A is a critical point, if the second derivative at A is greater than 0, okay, it's positive, that means it's concave up. That means A is a relative minimum. And vice versa is true. So if it's less than 0, that means A is a relative maximum. Okay. So we're going to take this idea, we're going to use it to find relative extrema. So relative maxes and mins. So first, just like before, anytime you're finding relative max and mins, step 1 is to take the derivative and set it equal to 0. So here we can pull out a 4x squared, and we get x minus 3. So my x values are 0 and 3. Okay. Those are my critical points. So what you could do here, and it's completely correct, is set up your sign chart, okay, plug in your first derivative, see where it's increasing and decreasing, and then you'll figure out your max and mins. Or if you don't want to do a sign chart, what you can do is plug into the second derivative. So take the second derivative, that's 12x squared minus 24x. Okay. And all you do is plug in these values, right? So f double prime of 0 is equal to 0. Okay. So that's not a max or a min, it's just a critical point. F double prime of 3, though, is going to be 12 times 9 minus 24 times 3, which is 12 times 9 is 108 minus 24 times 3, 72. So that's going to be a positive value. Okay? Therefore, it must be concave up at 3. Okay? If it's concave up, and we know the derivative is 0 there, it must be a minimum. So there's a relative min at 3, comma, and then to get your actual value, you plug into the original. So that's 81 minus 4 times 27 plus 2. Times 27. That's negative 27 plus 2, negative 25. All right, same thing but with trig. Okay, I know you guys have been struggling with trig, so let's try this. On trig, they would give you an interval, okay? So only from, this should be 0 to 2 pi. Okay? Otherwise, it keeps going and going and going. All right, so step 1, just like before in the first derivative test, we're going to take the derivative. Okay. Derivative of cosine is negative sine minus 1. All right, then we set it equal to 0. Negative 2 sine theta minus 1. So basically, I want to know when sine of theta equals 1 over 2, right? Add the 1, negative 1 over 2. Okay. All students take calc. So sine's going to be negative here and here. Okay. Sine of what is a half? Okay. That one, let's see. If you don't know your trig ratios, set up a little triangle. Sine of theta is 1 opposite over hypotenuse, 1 over 2. So remember, it's 1 to root 3. That makes this the 30-degree angle. Okay? And 30 degrees is pi over 6. But it's here and here. So it's going to be, this is pi, so 7 pi over 6. And 11 pi over 6, I believe. Okay. So all you do is you take your second derivative now. I wish I would have saved some room. So your second derivative is, and you just take the derivative of that. Derivative of sine is cosine, so negative 2 cosine theta. And you plug in these values. Cosine right here is going to be negative. So this one's going to be a negative times a negative, so positive. Okay. If it's positive, that means it's concave up and thus a min. So we have a min at 7 pi over 6. And then whatever that value is. You could just put it in your calculator. And then, because it's going to be ugly because you're going to have a fraction here. All right, and then a well, we don't know yet. So the second derivative at 11 pi over 6. Okay. So we got negative 2, so negative, and then cosine at 11 pi over 6 is actually positive. So a positive times a negative is a negative. So because it's negative, it's concave down, which makes it a max. So we're going to have a max, a relative max at 11 pi over 6. Then you just plug into your calculator to figure out that second value there. All right. 2 more examples. All right. So this one, I highly suggest step 1 is rewriting. And I want to know relative maxima and minima. So the first derivative will give us our critical points. So negative 3x squared plus 3, okay, equals 0. Take out a negative 3, so we get x squared minus 3, no, sorry, is minus 1 equals 0. So x is plus or minus 1, okay. Yes, you totally could set up a sign chart here. Or you can use the second derivative test, which requires a second derivative. So we're going to take that. That one's not too bad. Negative 6x. And then you just plug in. So g double prime of 1 is going to be a negative value. Therefore, it's concave down. And if you need to draw it, concave down, and thus a max at 1, comma, and then you just plug it in here. So 3 minus 1 plus 5, what's that, 7? Okay. And g double prime at negative 1, okay, will be negative times a negative, therefore a positive. Okay, that means it's concave up. Concave up implies a min at -1. And you just plug in, so -3 minus -1, so +1, so the -2, plus 5 is 3. All right, and last one, okay, we want to find the relative maximum and minima. So step 1, critical points. Take the derivative. Very similar to the last one. All right, and you set it equal to 0. Take out a 3x, so you get x plus 2. So your x values are 0 and -2. Yes, you could do a sign chart here, or, so you don't have to do one of those, you could take the second derivative, which in this case isn't crazy, so that's going to be 6x plus 6. Okay. And then plug in these values. So when I plug in 0, I get 6, which is positive, therefore concave up. So it looks like this. Therefore, it must be a relative minimum at 0. And then you can plug it into the original, so that's -2. Okay. The second derivative at -2, that's going to be -12 minus 6, so -6 is negative. Therefore, at that point, it's concave down, which looks like this. Thus, that must be a relative maximum, and that's my x value at -2. And then you plug in -2 to the original, so -8 plus 12 minus 2. That's going to be 4 minus 2, 2. Right? Yeah. All right, so that's the second derivative test. Not as complicated as it sounds. Remember, find critical points just like you did before. Plug them into second derivative. If that's positive at that value, it's concave up, which makes it a minimum or relative minimum, and then vice versa. So if you plug in your second derivative and it's negative, that means that the graph is concave down there, and therefore that critical point is a maximum. Okay. Yes, you could do this by a sign chart, or you can do this if you don't want to do a sign chart, especially if that second derivative is easy to take. All right, if you guys are done with these, you have all of this stuff done. Your homework is on the same page from last night. Also, go back to this page. So on the next pages, you have 15 graphs of polynomials. Okay. They could put into big groups. So you have all these different polynomials, and I want you to see if you can put them in together. All right? That's it for today. Have a great day. Get your work done.